Okay, this is lesson 7-2, Matrix Algebra. Now, a matrix is a rectangular array of numbers. So rectangular goes here. A rectangular array of numbers written within brackets, usually named by capital letters. In the example at right, a sub 2 times 3 actually it's read as A is a 2 by 3 matrix. That's what it means. Every item listed in a matrix is called an element. An element is identified by its position in the matrix. Each number has two indexes, the row and the column. The row is the M, the index M, and column is the index N. Any M by N matrix with the same number of rows as columns is known as a square matrix. The identity matrix, I, is a square matrix where the diagonal entries are ones and all other entries are zero. And you can see that here. You see how they're all listed. Okay, that's what it means. Now, you can add and subtract matrices as long as they are the same size. Okay, and you're going to add and subtract the corresponding places. So, like on example 1, we're given A and B, and we're going to add it in part A, subtract it in part B. And you just add and subtract their corresponding positions. So, like when we add them, you're going to add the 2 and the 5. That gives you 7. The 4 and the -2 would give you 2. The -3 and the 0 is -3, and so forth. So we'd end up with 3, 6, 10, -2, 3, -4. So notice it's the same size as it started with, and you're just adding corresponding parts. So those are the easy parts. You probably even had this already. On the subtraction one, it's the same thing. Just subtract the like things. Just be careful with your signs, because if you're subtracting a negative, remember you end up adding. So that's the only issue there. But you end up with -3, 6, -3, -5, -6, -8, 8, 1, and 0. Now the next part, we're looking at operations of matrices. So operations of matrices. Let A, B, and C be matrices of the order M by N. They do have to be the same size for these things to work. It does work for commutative property. Like you can add A plus B or B plus A. It's the same exact thing. It's the same thing that we've done before. Associative property means you can change the grouping. So you have A plus B plus C. It doesn't matter if you group, say, and add these two together first, or you want to add these two together first. You're going to get the same thing. The zero matrix property means a matrix plus 0 is the same matrix. Scalar multiplication is if you have some number, let's call it k, times basically these. It's kind of like distributive property. K times A, you multiply just every number, every element in that matrix by k on both of these. Okay, it's the same thing. So in example 2, notice they give us some things. They give us 3 different matrices here, and they're asking us to, like on part A, multiply the matrix A by 2, subtract from that 3 times the matrix B. So what I'm going to do is I'm going to do this part first. I'm going to multiply everything in this matrix by 2. So that gives me 10, 2, 6, 12, 0, and -4. Minus, and then I'm going to do 3 times everything in this one. So that would give me 0, 6, 12, -9, 3, and 24. Now I'm going to subtract it. Now if you want to rewrite it and change that to plus and change all the signs of the second one, you're more than welcome to do so, but you don't have to as long as you keep that straight in your mind. This would give us 10, -4, -6, 21, -3, -28, like that. That's our answer. Now in part B, we have 1/4 times C, so we're just going to take C and multiply by 1/4. We're basically dividing every number there by 4, so you get 3, 0, -1, and 2. Pretty straightforward. Now on to the next part, multiplying the matrices. That's a little bit more complicated. I'm not sure if you did this in Algebra 2 or not. It's not a big deal if you haven't. You can say you heard it here first. But basically, row by column matrix, you're just multiplying. It's kind of interesting. You're going these two times each other, plus these two times each other, plus da-da-da-da-da, like that. So it would be R1, C1, plus R2, C2, plus dot 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 plus all the way to R sub n, C sub n. So basically you're just kind of going down, matching them up. And then you multiply all those individual like corresponding locations together and then add them all up. Now the columns of A must equal the rows of B for that to work. So we're going to do one. Notice on example 3 of the top here, multiply R times C, and we're given R and C. So basically, we are multiplying these two times each other, the first one and the first one, so that gives us 6. And then we're going to add the next one. If I multiply those two together, that gives me -24. And then we multiply these two together, and that will give me a -20. So if we add that up, we get -38, and that is our answer. Okay, so sometimes it goes to a single number like that. It doesn't always do that, though. So for instance, when you're multiplying two matrices together, like on example 4 and 5, watch what this one looks like. Okay, so it depends, because remember when you're multiplying, the order matters here on the size and shape of the answer. So it is a little bit different. So if we multiply A times B, then I'm going to have to, yeah, this is interesting. I'm going to have to switch this around a little bit. Change my B. Well, actually, you know what? I got B times A. No, I'm going to go down like this, across. So this is 6 plus 1 plus 6 for that first one. 6 plus 1 plus 6, okay? Then this would be 0 plus 1 plus 4. Then on the bottom to the first row, we're saying -2 plus 1 plus 0. And then we're going 0 plus 1 plus 0. Okay, so this is basically, and I wrote the steps. I don't always do that. A lot of times I just do it in my head, but sometimes you get such large numbers, it's kind of difficult. So this would give us 13, -1, 5, and 1. So that's our final answer. So notice I kind of showed the process of doing it. Now if I'm doing B times A, I'm going to go ahead and write A over here just to make it easier for me to kind of see it in this order, because this messes with my mind to go backwards. So I'm just looking at these two. So on this one, I'm going this way. Okay, so this is 2, might be easier to write it. This is 6 plus 0. This one would be 3 plus -1. This would be 9 plus -2. Then this would be 2 and 0. 1 and 1. 3 and 2. And then the last row here, that would be 4 and 0. This would be 2 and 0. And 6 and 0. So it's kind of hard to kind of keep that straight. Let's see, so that would be 6, 2, 7, 2, 2, 5, 4, 2, 6. So there's our final answer. So notice how the size and the shape of what's left is different depending on the order of the matrices. So interesting. Okay, now the next part says determine the determinant of a square matrix. So the inverse of a 2 by 2 matrix would be, let's see, if they're given the generic A, B, C, D, and we got to make sure that, of course, AD times BC is not equal to 0, then the inverse matrix, which is denoted by that -1 thing there, would be 1 over A times D minus B times C times D A, and then negative C, negative B. Okay, so what you're doing here is you're switching these two around and then changing the sign of those two. And then you're going this times each other minus this times each other. And that's what's on the bottom. Now, I do want to add this right here. It's not in our notes, but I think it comes up in a little bit. Okay, the discriminant, hopefully I spelled that right for you guys, is denoted by that bar, and it says A, B, C, D. That is AD. Oh, darn, I run out of space. I'll move it down. AD minus BC. Okay, so that's what that is equal to. That's called the discriminant. So if you see that somewhere, that's what it is. That's what it means. Oh, look, it says it right here. That is the discriminant. I guess I didn't need to write it on the side. It's there anyway. Oh, first time we're going through it, guys. Forgive me. So notice at the bottom it says let A be a square n by n matrix. If there exists an n by n matrix that is the inverse, A inverse, then if you multiply them together, you'll get the identity matrix. So that's one way you can kind of test it out and you can know. So let's see what else we've got. Okay, example 6. All right, on this one, it says find the inverse. So we're actually going to do that. We're going to find the inverse. So the first thing we want to do is do the discriminant, which is this times this, so that's -3, minus this times this, so that's 2, which gives me -5. So I know my inverse would be 1 over -5 times, and then I flip these two around. So that's going to put the -1 up here and the 3 down there. And then I just change the signs of those two and leave them in the same spot. So this would be -1, -2. So then if I multiply that, that's a positive, so I don't even need to put a plus. 1/5, 1/5, 2/5, and a -3/5. So that is our inverse. So it's not hard. You just kind of remember how actually to do it. Now you can find the inverse of a matrix using your calculator, the TI-84 plus CE. Hopefully you guys have that. I know most of you have this at home already, just because I've seen it. If you don't, then I guess you don't have to do it. You can just do it the long way. It's not a big deal. We'll make adjustments for this, in this time we will figure it out. But if you have access to one, I'm not sure if it does it on like whatever that Desmos, that's what I was thinking of, or any of the online calculator things. It might. You can try it on there if you like. The screens are all right here. So if you have it at home, you can do it. I happen to have one of these at home because I brought it home. I don't have enough for everyone, so sorry. We'll figure it out. Okay, just let me know if there's an issue and you can't do it, or if you can't find an online way to do it or something like that. We'll see what we can figure out, or just postpone that portion until we do get back to school at some point. So if we were going to do this, and I'm going to put it in, let's see, find the inverse matrix of this, then the first thing you want to do is actually type in the matrix. So click on, oops, not that one. Click, see how the matrix is right here in the blue? So we got to hit second and then the blue matrix. And you can tell I've already done quite a few of these already when I was working the lessons and all. So I'm just going to go over to edit, enter, and I'm going to edit A. just because, why not? I've already used this, right? Okay, so first you're going to put in what size matrix it is. So this one's a 3 by 3 because it's 3 rows, 3 columns. So it's 3 by 3, so that part's the same. So then I'm going to go to this, and when you enter them in, I'm going to enter it in exactly like I see there, and I can just hit enter and go straight across, okay? And it's going to enter it and put it in the right place for you. So 1, enter, -1, enter, 2, enter, 2, enter, 1, enter, -1, enter, 0, enter, 2, enter, -2, enter. So just enter it all in like I just did. And now we can go second, quit, and get out of it. So we want to find the inverse. So we're going to do, let's see if I remember how to do this. Second matrix, we're going to go to math. And do they have inverse on here? Is this where I saw it? I should have did this before I started recording, huh? Nope, it's not there. Okay, so names. So we're going to put, I'm going to try this. I'm going to just hit matrix on the name to show the matrix name that I named, the one that I just put in. And then I'm going to go, where's it at? Oh, that X -1 button. The one right, the actual matrix button. You see how it gives you the little -1? So that actually will give us the inverse because that's how we show it. So we're going to hit enter. And voila, it's magic. We have it. That's our answer. And all we have to do is actually write it down. So I'm going to move it over. So our inverse here is 0, 1/2, -1/4, 1, -1/2, 5/4, 1, -1/2, and what is that, 3/4, if I can see that correctly. So it's so much nicer to be able to do that in your calculator. If you don't have one, like I said, try it out with something. If not, I guess you can skip that one. Don't worry about it. Okay, so number 8 down at the bottom over here says verify that this times that is the other. Don't worry about this. We're just going to omit that one, okay? So you are officially done with this particular lesson.